In today's class, I'll be talking on Sturm Liouville system. A boundary problem can be described by the differential equation of the general form. What do we call a Sturm Liouville system? Uh, if you come across to my channel before, you can see that I've explained on Sturm Liouville problem what related to it already. When I talk on this related to it and some condition on it, boundary condition. But in this video, we are still on Sturm Liouville problem. But in this one, we are going to find what this lambda represents. How we are going to look for the solution for this. The one and I uploaded before, I discussed on my channel. I discussed on if you see a homogeneous differential equation, second order homogeneous differential equation, how can we say it satisfies Sturm Liouville system? Is it a form of Sturm Liouville system or not? And we consider this boundary condition alpha and beta, where I say alpha and beta are real constants. And also I said our P of x, Q of x and R of x are what? They are what? They are continuous on A and B. So in this one, what I write on the board, I said a boundary problem can be described by the differential equation of the general form. In Sturm Liouville system, the order is 2. The order is 2, that is a second order. That is P of x y prime. We can see another prime here. Plus Q of x plus lambda R of x y is equal to what? Is equal to 0. So whenever we have equality to 0, it means it's an homogeneous differential equation. You can see that a good example is if I have g of s is equal to 0, this is homogeneous. But if our g of s is not equal to 0, it is what? We call it as what? It is non-homogeneous. You can see that for a is less than or equal to s less than or equal to b, and r of s is greater than 0, where the boundary condition can be written in the form of alpha 1 y of a plus alpha 2 y prime of a is equal to 0, beta 1 y prime y of b plus beta 2 y prime of b is equal to 0. I've explained this. If I have y prime, this thing means dy over dx, that is the derivative of what? Y, that is dy dx, is a first order. If I have y double prime, that is the second order, is a second order derivative, that is the square 1 over what? The x square. So if I have y prime here, I have prime outside, so it means y prime and prime. So y prime is what? First differential equation, that is first I differentiate first derivative. Y prime means first derivative, y double prime means second derivative. That's the square y all over dx square. With respect to what? With respect to what? If I have with if y is the function with respect to x. So in this video, in this I have for a is less than s less than or equal to b. This is a continuous, this is continuous interval. I can write my continuous interval as a, my continuous a is less than s, a is less than s or less than or equal to b is a continuous interval. I can write it as a comma b. This thing, it means our s here is a member of a, is also a member of what? B. If I have a continuous function, anything related to a continuous function or continuous function, it means it is a well defined. But this is a what? Is a continuous interval. You can see my interval here. I have a closed set, another closed set. It means a and b here is what? But a, my s is here is a, my b here is what? It's also my s is equal to a, my s is equal to what? B. So when I talk about a continuous function, a function is said to be continuous if f of s over g of s is where g of s is not equal to 0. So a continuous function is well defined. So when function is continuity, when function is continuous, it means that it is an easily route I can draw. If I have 0 is less than less than or equal to s less than or equal to what? 1. You can see from here, my continuous interval for this is 0, 1. You can see that what? After 0, let's say 0, after what is next to 0 is 1. You can see that after what is next to 1 is 2. You can see those numbers move smoothly. When you have something move smoothly without no disturbance or something, you call it a what? You call it a continuous function. So it's also a good example is a smooth road is a continuous function. A smooth road will not have a potholes, So in this video, I'll be considering, you can see that what do we have here? P of x y prime prime plus q of x plus lambda r of x y. Our p of x, q of x, and r of x are continuous function. Then our alpha 1, alpha 2, beta 1, beta 2, they are real constants. So when we talk about a boundary condition, a boundary condition means when we have a homogeneous, when we have an equation, we'll be given some problem, that is the condition problem. It can be initial value problem. We have initial value problem, we have boundary value problem. So boundary condition. In some, what do you have here? So boundary condition can be written as in the form of this. You can see that we have a boundary condition that is our a, y of a, y of a, y prime of a, then y of b, y prime of b. So we have initial condition, we have boundary condition. So initial condition is an ODE together with what? Initial, and I will call it initial value problem. Initial value problem is an ODE together with an initial condition. But in solvable problem, we have a boundary condition, boundary value problem, that is an ODE together with what? Boundary condition. So that is in our boundary condition, our condition cannot only be 0, can be 0, 1, but it will never be 0, 0. It's a continuous function where we have our s is equal to a, s is equal to what? B. So in this solvable system, we'll be considering this sign here is called lambda. Equation we call it, we call it eigenvalue. So in this problem, in this solvable problem, we will look at some example, some problem related to this. How can we solve this lambda? How can we consider this lambda? How can we solve it? Then we are going to solve how can we get eigenvalue and eigenfunction for this problem. Another thing is that p of x, y prime and prime, if I have something like this, I can open this bracket as I have p of x, y prime. I also have another one here. I can open this. If I want to open this, I can open this one, p of x, y prime and prime. So this is a product. Take this one, multiply by this. I'm going to have p of x, y prime prime plus, I have one here. This is a product rule. I want to differentiate them. I have prime here is what? First derivative. So first derivative of this, I can write that d over dx is the first derivative of p of x, y prime. So it means if I differentiate this one, x, I'm going to have 1. If I use that one to multiply this, I'm going to have this p of x, y prime. So it means I have expressed this outside. I have solved this. I've opened this bracket by this. Then we now have the minimum plus q of x plus lambda r of x, y is equal to 0. So you can see that this I can write this one as this. So I've opened this bracket. When I open this bracket, I have this as well. Then with this one, I got this for what? The one that I have. So a solvable problem is when you have a system that is in form of this one, we call it a what? It's called a Sturm Liouville system. That is just it. If it satisfies all this, we call it a Sturm Liouville problem. So in our next video, we'll be talking on some problems, some exercise and some problems related to what? Related to Sturm Liouville system. How can we find this eigenvalue? Thanks.